Welcome to my session here at Spring.io. I think I have catched you with the keyword GraalVM. Many of you will already know GraalVM because of its native image compiler. Native image is a technology we can use to compile Java applications ahead of time so that we can start them with a very fast startup time and a low memory footprint in the cloud. Native image is one of the most hyped new features in Spring Boot 3 and also here at the conference. And also, in my opinion, native image and GraalVM in general will have a huge impact on cloud native development with Spring and Java. This is the reason why I started to use GraalVM and native image directly when the technology became experimental in Spring Boot 2. So while most companies are starting now to use native image, I am already using the next big feature of GraalVM, which is called polyglot. Polyglot means that we can run programming languages like Python or JavaScript and also the packages from those languages like JVM-languages directly in Spring. So my session today, empower your Spring applications with Python features on GraalVM, is not about native image. My session is about polyglot. To show you polyglot programming, we will set up a Spring Boot application and use in the Spring Boot application Python and the package NumPy to do some data science calculations directly in Spring. At this example, you will see that based on polyglot programming, we can use the Spring framework for use cases we never used it before. I hope you will enjoy the session, and before we are going to start, I want to introduce myself. My name is Johannes. I am working at Exeta in Karlsruhe in Germany. Exeta is an IT consulting company, and I'm working there as an IT consultant for cloud native development, mostly with Spring and Kotlin. To show you how to use Spring and Python, I have the following roadmap. First of all, the motivation. So why should we use Python as like a programming language in Spring Boot? Here I have a practical use case for my company where we are using Python in Spring Boot. And we are using Python and Spring Boot for a small data science application. And at this example, you will see that polyglot programming is simplifying our development process and also our architecture in the cloud a lot. After the motivation, we will have a look on the theoretical backgrounds of GraalVM. So here I will explain what GraalVM is and how GraalVM works so that it's possible to use Python like a JVM language. Then we will switch into the most interesting part, the demonstration. So here I will share the code of a Spring Boot application, and here we are using Python and NumPy for some data science calculations directly in Spring. So you will learn how to set up the application, how to use Python and NumPy, and finally, we will have a look on the Dockerfile, so that after my last point, the conclusion, you're ready to directly implement and deploy your own polyglot application in the cloud. I am already running a polyglot application in the cloud, and this application is called the Project Matcher. So as I told, I'm working at an IT consulting company, and so we are getting every day new opportunities to do projects at our customers. And so we are facing every day the challenge to find the perfect fitting consultants for those new projects from all the people in our company. And as you can think, searching the perfect fitting employees manually is a very complex and time-consuming task, because we had to scan the profiles of all people by hand. So we decided to implement an automated solution in form of a recommender system. A recommender system is an application which is scanning the profiles of all people in the company automatically and is returning the perfect fitting candidates within milliseconds. And this recommender system is called the project matcher. When we started to implement the project matcher, like in every data science application, we first of all had the challenge to collect the data our recommender system is based on. So the first thing we did was to set up a data store. In our application, the data store is storing objects of the type employee. Here you can see the Java class, and you can see every employee in the company has an identifier, a name, and a list of skills, while in our application, every skill is just a string. To update and maintain the data store, we built a Spring Boot application around this employee class, and here we exposed some REST endpoints, like get, put, post, delete, and these endpoints our employees can use to update their profiles. So you can see, until here, it's a normal and simple Spring Boot application implemented in Java. Now we have our data store, and now we can start to implement the recommender system. So first of all, we exposed a new endpoint called post recommendation. And at this endpoint, we are accepting the request body project, again, as a Java class. And you can see, again, here are a list of skills. And again, every skill is just a string. So these are the required skills for our project. And now we have to find the employees which are the best match for those skills. As developers, we now have to implement this function. The function is called recommend employees, and it's getting two arguments. The first argument is the project, so the project we want to find the employees for. And here are the employees, so all employees in the company in our data store. And the return, again, is a list of employees, and these are the best fitting candidates for the project. As you can see, we decided to implement the function not in Java. We decided to implement the function in Python. Python is providing some great data science packages like NumPy, and in these data science packages, a lot of recommendation logic is happening in the background. So for us, it's possible to implement this more or less recommendation function in just a few lines of code. And so I think it's a very good decision to implement this function in Python. But if we are zooming out from the function and have a look on our architecture, we will see some very important drawbacks of the implementation. Let's first of all have a look on the architecture before we implemented the function. So you can see here's our Amazon Kubernetes, and in this cluster are running all our internal tools, and like every internal tool, there's also running our Spring Boot application. Now we want to use the recommendation function. If we are using the recommendation function the traditional way, we have to set up a new microservice in the cluster. And here you can see directly the drawbacks of the implementation. So first of all, in my opinion, the microservice itself. We have a very small recommendation function, and just to use these few lines of code, we have to set up a complete new microservice, we have to set up a pod, and finally we have to set up a web framework to get requests and send responses. So a lot of overhead just to use the small function. Additionally, we have to re-implement all our existing Java models again in Python to use them also in this microservice. And finally, you can see it here in the middle, we have to send all our employees from the company through the network, so the network traffic is increasing a lot, and so also the response time for our clients. In my opinion, it would be a much better solution if we could use Python like a JVM language directly in Spring. Like this. In this case, we don't have to to set up and maintain the new microservice. We also we don't have to re-implement the models from Java and Python, because we can just import them. And finally, we don't have the network traffic overhead, because we can just call the Python function from Java and return again the results back in Java and return it at our endpoint. And this is exactly what GraalVM allows us to do. So based on GraalVM, we can use the Python function like a Java function directly in the Spring framework. Now you think, I never heard before that someone is using Python in Spring. Why is it working? So let's have a look on GraalVM. Some people I talked to thought GraalVM is only the native image compiler. But in reality, native image is only one feature of GraalVM, because GraalVM is a whole JDK. GraalVM is based on OpenJDK, and like every JDK, also GraalVM has, on the one hand, some development tools, like compilers, debuggers, and so on. And on the other hand, it has its own Java runtime environment, and also its own implementation of the Java virtual machine. The Java virtual machine in GraalVM is called GraalVM. So GraalVM is the JDK and the Java virtual machine. And this Java virtual machine is able to run code from languages like Python or JavaScript. To understand why this is possible, we have to look at a sister project of GraalVM, which is called Truffle. Truffle is a Java framework we can use to implement interpreters for any programming language we want. If we want to use Truffle, we have to implement the following steps. In the first step, we have our source code. This is a program in any language, for example, in Python. For Truffle, it's only a normal text file. In the next step, we transfer the source code into the data structure of a tree. And now we take Truffle to annotate the nodes in the tree so that the interpreter knows how to run the nodes in the tree. And the result is a so-called abstract syntax tree. Let's have an example to understand this. We want to implement an interpreter for the program 1 + 2. So in the first step, we are transferring 1 + 2 into the data structure of a tree. So we have two child nodes, 1 and 2, and we have a parent node, the plus. Now we take Truffle to annotate the nodes in the tree. So we say our two child nodes, 1 and 2, are the data type integer from Java. And if we want to get a result in the parent node, we just add those two child nodes, and the result here is again an integer. And now we have an interpreter for our small program. But why is it important to know Truffle? The reason is that GraalVM, the virtual machine, is able to understand those Truffle trees. And this is the big difference between GraalVM and any other JDK I know. So for example, if we are comparing OpenJDK with GraalVM, OpenJDK is only able to run code from Java JVM languages like Java or Kotlin. In difference, GraalVM is also able to run code from JVM languages, but in addition, it's also able to run a programming language we have a truffle interpreter for. And so we can run every programming language with a truffle interpreter directly on GraalVM. And the good message is we don't even have to implement those interpreters on ourselves, because the GraalVM team has already implemented a lot of interpreters for us. So for example, for JavaScript, for Ruby, for R, and also for Python. And so we can install these interpreters on our in our JDK and use these programming languages like JVM languages in Spring. And now I will show you how this is working. So I will switch into the code. Here you can see my, my Spring Boot project. And before we are going into the implementation, I first of all want to show you the Dockerfile. Here you can see how to set up the application. Is it possible to see the code in the? Okay, nice. So this is the way how to set up the project and deploy the application in the cloud. Let's start in the first line. Here we are setting up the JDK. So you can see we are going to use GraalVM, the community edition, and we are downloading it from the GitHub registry. On the right side, here is the specific version we want to use. And you can read this in the first parameter is the operating system, so Oracle Linux 7. Then the Java version we want to use. Here we are going to use Java 17 because we use Spring Boot 3. And finally, the version of GraalVM. Then I'm going to set up some tools to download packages from the internet. It's not very interesting. More interesting is this part, because here we set up Python and NumPy. So first of all, in line 7, we use the tool GU to install Python on GraalVM. GU is the short form for Graal Updater, and the Graal Updater is a utility tool for GraalVM we can use to install functionalities which are not in the standard of GraalVM. And not in the standard are all the truffle interpreters, so we have to install them explicit if we want to use them. So we installed the truffle interpreter for Python, and this is called, the truffle interpreter is called GraalPy. We can use the tool now in line 8, 9, and 10. In line 8 and 9, we set up a virtual environment. This is required in Python if we, for example, want to use additional packages. And we want to use an additional package, NumPy. This we are installing in line 10. So here you can see GraalPy, and we install NumPy. For the installation, we use ginstall. Ginstall is a package manager from GraalVM. It's also possible to use any other package manager, like, for example, pip. So you can choose what you are preferring. After the installation of Python and NumPy, I'm setting up Maven, and I'm setting up the Spring Boot project. It's exactly the same like in OpenJDK, so I will skip this. In short, the most important lines. Line 1, to set up the JDK. Line 7, to set up Python. 8 and 9, to set up the virtual environment. and finally line 10 to install NumPy. So now we have a JDK, we can use Python, and we can use NumPy. Let's have a look at the code now. So source main, and here you can see the first big difference between my project and I think most other Spring Boot projects you have you worked on, because here we have Java, okay, like in every project, and here now is Python listed like a JVM language. So it's looking like Python is like Kotlin, a JVM language. Let's go into the Java folder. Here you can see the both models you already know from PowerPoint. We have the employee object. It's a normal class in Java, and we use Spring Data to store the object in the database. The other model is the project, and it's a Java record we accept as a request body at the post endpoint. Both models we use in our controller. And here you can see we have a REST controller, and this REST controller has two services. The first service is the employee service, and this employee service has a dependency to a CRUD repository to access the database. This service is not very interesting because it's implemented in Java, and it's exactly the same like in every other Spring Boot application. We use it here at our REST endpoint, for example, for the get, post, and delete endpoints. More interesting for you is the recommendation service, because this recommendation service we use at the recommendation endpoint. So you can see here, we are accepting the request body project, and we call the recommendation function you already know from the PowerPoint. So we get the two arguments, the project with the required skills, and all the employees in the database. What is the recommendation service now? The recommendation service is just an interface in Java. You can see here, it's the interface, and here is the function we want to use for the recommendation. The implementation of this interface is not coming from Java, it's injected from Python. So you can see my package structure, com, exeta, project matcher, service, and here's the recommendation service interface. Now we go into Python, and here you can see again the package structure, com, exeta, project matcher, service, and here's the recommendation service implementation. And this recommendation service implementation we want now to use in Java. So I set up a new configuration. And here I set up a string Python path, and this is the path where we can find the implementation. So you can see here again the package structure from Java and Python. Com, exeta, project matcher, service. This string we are going to use inside this bean definition. So you can see we have here the bean definition, and the return is an implementation for the recommendation service interface. The first thing we are going to do is to set up here a new context. You can think of the context, it's like opening a new sandbox on the Java virtual machine. In this sandbox, we are going to use the programming language Python. Because it's a sandbox, it has no permissions to do anything. we are changing it here. So here we allow the sandbox, for example, to access the file system and the network. For example, to import packages like NumPy. Then I have to add two options. The first option, force import site, is required if we want to use additional packages like NumPy. So I have to set this option to true, that Python can find this package. In the next line, I'm going to set up the Python path. This is required if we want to use additional files we have implemented in Python. For example, if you are implementing a service and you want to use models you have implemented, then this option is required. And then our context is finished. So in short, we set up a new context. In this context is running Python. Python is allowed to access the file system, so we can import packages like NumPy, and also we can import additional files we have implemented. Now the context is finished. Now we want to use a program in the service, and this is happening here. So we set up a new source. This source is implemented in Python, and we can find our source file at the Python path, the package structure we set in the Python path, and the file is called recommendation service implementation.py. So it's this file here. Now we have a context. In this context is running Python, and we have our source file. So now we want to put the source into the context. And this is happening here in line 42. So we have the context, we put the source into the context, and now GraalVM is scanning the file, and we can use the implementation. This is happening here. So from the context implemented in Python, we want to get the class recommendation service implementation, and we want to use it as an implementation for the recommendation service interface. And these two lines here are my favorite lines in the whole presentation, because you can see, based on GraalVM, it's not only possible to add some integers or reverse a string, for example. You can see we can use whole implementations for classes as implementations for an interface. And now we can use the recommendation service implementation in our Java application like a normal Java class. Let's have now a look at the implementation in Python. And here you can see, first of all, we want to use the objects employee and project. And we don't have to re-implement them. We can just import them here from our Java code. And now we can use those classes here in the Python implementation like normal Python classes. And you can also see, for example, here and here, also the functions are implemented in the code. So if we're going to change the Java implementation, the classes are automatically changed in Python for us. So now let's go into the recommend employees function. You can see here again the project, the employees in the company, and the list of employees we are going to recommend for the new project. What we are doing now is to implement an Euclidean distance calculation. First of all, we set up a project vector. So we are iterating through all the skills in the project, and we are mapping every skill to the value 1, to the integer 1. Then the project vector is finished. In the next lines here, we are iterating through all the employees, and here we are mapping for every required skill from the project the skills in the employee to 1 if the employee has the skill, or to 0 if the employee has not the skill. So we have now two types of vectors, a vector for the project and a vector for every employee. Now we can use those two vectors for the calculation of the distances, and here we use NumPy for the calculation of the distance. And you can see here the project vector and the skill vector of every employee. And here you can see we use NumPy for the calculation, and it's now possible to solve our problem in just one line of code here. Now we get the distances, and the best fitting candidates for our project are those employees who have the smallest distance to the project. So we can now start to order all our employees, and now on top of the list there are the best fitting candidates of the project. And they we can return here back to our Java code. So you can see it here. We say return the list. We return the list. The list is a list of employees, and we can use the result here at the post endpoint to return those employees to our clients. I think now you want to see how it's working. Let's switch to my Postman collection. I have already started the application. And first of all, let's search the employees, all employees in the database. It's the normal Java endpoint. So you can see I have already, close this. I already added 3 employees to my company. My first employee is Alice. She is the cloud developer in the company. So she has the skills Spring Boot, Kotlin, and AWS. My second employee is Bob. He is the expert for GraalVM. So he has the skills Spring Boot, Java, and GraalVM. And my last employee is Carol. She is the app developer. So she has the skills Android, Kotlin, and Java. Okay, now let's search for, now we get a new project request, and we have to find someone who is expert for GraalVM development. So we are searching for the skills Spring Boot and GraalVM. The expectation now, Bob is on top of the list because he has the skills Spring Boot and GraalVM. Alice is at the second position because she has only the skills Spring Boot. And Carol is on the last position because she has no of the required skills. Let's test the endpoint. We have here the required skills for the project, GraalVM and Spring Boot. We send a request. And you can see Bob is on top of the list because he has both required skills, Spring Boot and GraalVM. Alice is at the second position because she has the skill Spring Boot. And Carol is on the last position because she has no required skills. Also, you can see here the response time is very fast. So for a client of the application, the clients don't recognize that in the background we are using Python because the response time is like in a normal Spring Boot application very fast. Let's have another example. Let's search for cloud development. So now we want to find an expert with the skills Spring Boot and AWS. Expectation now, Alice is on top of the list because Alice has both required skills. Bob is at the second position because he has only the skills Spring Boot. And again, Carol is at the last position because again, she has no required skills. And you can see again, the response time is very fast, and Alice is on top of the list. Bob is at the second position, and finally there's Carol. Now let's have a look if our application is enterprise ready. So is it possible to test the code? Back into the code, and let's switch into the test folder. And here you can see, first of all, the test unit and integration tests for our controller. And here, because the implementation or the recommendation service is an interface, it's very simple to write tests here. So for the unit tests, we can just use Mockito to mock the employee service, and it's working like we are testing a normal interface. Also, the integration tests, here we can just set up the Spring Boot application as a Spring Boot test. We are starting the context, the Python implementation gets injected, and so we can use now, we can test now the controller with WebMVC, for example, like every other Spring Boot application. More interesting are the tests of our service. And here I'm recommending to use, to write not unit tests. You should write every unit test as an integration test. It's possible, for example, to use unit tests in Python to test the implementation, but because we are importing the Java models in our Python code, it's getting a bit complicated, so you can do it, but you will have a bit overhead. So I would recommend to just write Spring Boot integration tests, and so you can auto-wire the recommendation service, and now you can write unit tests in Java for your Python implementation, and the result is exactly the same like you're writing unit tests in Python. So you can see our code is very good testable. Let's switch back to my PowerPoint. And let's skip to the conclusion. So I think you saw that it's possible, based on GraalVM, to use, it's possible to use the features from Python directly in your Spring Boot application. And it's also possible to use them and to test them. So the integration of Python features in Spring Boot is working very good. But what does it mean for enterprise development in general? Here I like the idea of polyglot programming very much. Normally, you know that there are many different programming languages. And every programming language has its own benefits for specific use cases. But every time we decide to use a programming language for our microservice or our project, we automatically decide against all the other programming languages. And here, GraalVM Polyglot removes these borders. So based on polyglot programming, we can use the features from all programming languages which are perfect for the functionality we want to implement. And this is the idea I like very much about polyglot programming. And so I hope you will also use polyglot programming in your next application to empower this application on GraalVM. Thank you very much. You can find my code on the GitHub. I hope you enjoyed the session.
So finally, we can make Josh Long's dream ready by incorporating PHP into Spring Boot.
Yes.
I hope you will enjoy it. But I have a serious question. What's the impact on the startup of the application context? Because it's bootstrapping Python and doing stuff in the background, I think.
The startup time is increasing, so it's getting a bit longer. And here the most negative message is, right now, it's not possible to use the combination of Spring Boot, Python, and native image. So right now, you need some features which are activated in Spring, and they are deactivated. You have to deactivate them in Truffle, and so it's not working in Spring Boot right now. But there's already a discussion in GitHub, and GraalVM team is working on this. So I think the startup time will be fixed in the next releases.
Cool, thank you. Can I ask another question?
Yeah.
If you change the Python source code and you compile the application again, I guess it's failing at runtime, right? It does not do the checking that for example, your Python code uses your changed Java class.
Yes, so right now, this is the reason why I'm using VS Code right now, because normally I use IntelliJ, but in VS Code there are some packages or some packages you can install. There's the support better, but right now there you need the tests to find this, yes.
Okay, thank you.
Hi. So you said that this GraalVM supports this truffle framework and so on and so forth, but isn't it possible in a standard JVM, in an OpenJDK JVM with the GraalVM library to do the same thing?
No. And right now you need the GraalVM JDK to. So it's a feature. So it's the polyglot is not a feature you are getting from Maven. It's a feature which is directly in the JDK, so it's required to use the JDK.
No, I'm not saying Maven. I know there's a GraalVM library, polyglot library, which you can import into a normal JDK and have the same context and polyglot thing, right? Or do you think you seem to suggest it's something bound to the GraalVM JVM?
So as I know, I did this also in my code. I can share it here. So in my POM, no. Okay, VS Code doesn't want anymore. In my code, there I have also imported the GraalVM dependency, but it's only required if you want to find the packages in your IDE. So the scope is provided, and I only use them for my IDE, but not for runtime.
Okay. And if I can dare another question, is this when you import a Python into the Docker image, you installing a full Python interpreter there, and which you call from when you execute the program, or?
Yes.
So it's literally the executable is the Python interpreter. It's not the abstract syntax tree compiled only one time and then running only the JVM?
So the abstract syntax tree is happening in the background. So the compiler, so the interpreter is getting my file, it's importing the file, and then the interpreter is doing the tree logic in the background.
The Python interpreter?
Yes. From GraalVM, so it's not a normal Python interpreter.
Okay.
So you're saying we're calling the Python interpreter from our normal JIT compiled Java bytecode.
Yes.
So we do not get any optimizations for the Python code?
This is the very good question. We get a lot of optimizations. You can see it here. Because GraalVM is understanding this tree. And so GraalVM is scanning now the tree, and what's in reality happening, not this code gets executed. GraalVM would recognize it's too much overhead. I could directly write 3 here. And so if we are implementing a simple interpreter, GraalVM is doing a lot of optimization in the background.
So things like constant folding work, for example.
Sorry?
So things like constant folding work, for example.
This I don't.
Okay,
I
answer that one. So
Let me just get the microphone to her, and then I'll.
So I just want to address both, I just want to address your question and the previous question. So technically, I guess you can run it on a stock JDK because it's a Java interpreter, but you don't need the GraalVM compiler because under the hood, our compiler will optimize both the Python interpreter and your application code. So A, there are still optimizations happening coming from the GraalVM compiler, and B, you need the GraalVM JDK because under the hood, it still needs GraalVM compiler for the best peak performance. So it's an interpreter, but it's still relying on the GraalVM compiler to optimize the whole program. So we are still optimizing both the interpreter and the program, even though it's an Python code and it's an interpreter. So long story short, you don't need the GraalVM compiler. That's why you need the GraalVM JDK, even though you are importing the polyglot API. Thank you.
So in the code you had a bean with where you did find the context and source and so does it somehow, the more beans you have, does it add overhead every time you do this, or?
You can put multiple implementations in one context,
Okay.
so this is working, and it's also possible, this is the reason why I had always to write, I want to use Python, I want to use Python,
yeah.
because you can also put multiple programming languages in one context.
Okay.
And then it makes more sense to write, for example, now from my context, I want to use Node. Now I want to use Python. So,
And in the slide as well, at the end, you said you have 2 favorite lines. So if you could quickly jump to the...
which one do you mean?
in the code, I think you showed, sorry, in the config file, sorry.
I will open it now in IntelliJ.
So if you go to the, I think, Python configuration file, I suppose.
So, okay.
No, Python configuration file, the Spring configuration. Yeah, so the 2 lines which you said, those are your favorite lines?
Yes.
Yeah, so the get member, so the name you've mentioned there, what does it do? So identifier, but where are you defining this?
It's this
Yeah.
here is the name from my Python code.
So it has to be exactly that name of the class.
Yes, it's matching the name of the class here.
Okay. Okay.
Here in the last is someone.
Just a quick question. You could theoretically do like auto configuration relatively easily, right? Like create
Yes.
and starter for Python in.
This is also an idea I like very much, because if we would use now the implementation to write a starter, nobody. So you have, of course, you have to use GraalVM in your whole project. But if I'm going to use the recommendation implementation from a starter, nobody would ever see the implementation is written in Python. So this is an idea I like also very much.
So you want a question, and they.
Here in the last, he is the whole time.
Sorry. Okay. Yeah.
Thank you. We're mixing here a static and a dynamically typed language, so I was a bit worried. What happens if I want to modify the Java types, like adding attributes, or if I want to return like a NumPy array or pandas data frames? Is this supported, or will it just throw an error?
By NumPy arrays, I don't know, to be honest, but you can see it here also in the implementation. This list here is a Python list. And so, and in the return, in the controller, it's a Java list. So the mapping of the standard types are working very good. If they're working also from NumPy, I would have to check them.
So if I take like the employee class and add a new field, I don't know, middle name, just on one instance and return that, will it also work? Will the field not be there, or will it just break?
It should work, because if you would add here at the model a new field, here I'm using Lombok, and you can see here the import is working. So you would just get a new getter, and now you could, for example, return a string. So it would work.
But I could also add it in the Python, right? So I can just say employee variable dot middle name equals some value. So because it's that dynamically typed.
So you want to import the Java class, add a new attribute. Interesting question. You could try in my code.
I will. Thanks.
Thank you.
I would say it's the last question. I will be outside because I think the next one is waiting already. But yes.
I quickly want to ask one question. If I understood correctly, you mentioned there are some challenges with unit tests written in Python.
Sorry,
Okay, should I repeat?
I didn't hear it, so again, please.
You mentioned there are challenges in Python unit tests. Could you please elaborate quickly which kind of challenges you faced?
The core problem in my code is this import here. So it's not possible for me to use a standard Python implementation and a standard Python interpreter for the tests. So I have to run my code on the JDK to test the Python code. And so this is the reason why it's getting a bit complicated. Because if I want to test the code now on the JDK, I have to import these types without a new context, and then I have to add, for example, some annotations with hints how to import the models. And this is the reason why it's getting a bit complicated. But if you would not import Python classes, Java classes, you could write normal Python tests. So thank you very much.